okay, that's like the fourth time I'm giving this talk. So I rewrote it yesterday and added a lot of stuff, so we'll see how that's going to turn out. It's also renamed from 9 Postgres features to $X Postgres features because I didn't know how many features. Is it big enough or should I make it bigger? Big enough?
Bigger.
Always bigger. Blah, 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 blah. I'm from Järvebjerg, I'm also from Eiskibjerg, so I cycled to this conference. It's a big achievement because it was like 3 kilometers. Okay, so, it seems to be 12 Postgres features I wish I learned earlier, and 4 I learned right away. So I just start the stuff without the bad examples. Connecting to the database, usually do something like that. Postgres connect to the database, the username and the password. Type in the password is wrong. Fuck. And then I had this other project, which I inherited, and I took a look at the source code to figure out how it's actually connected to the database. So I grabbed for that thing and got like stuff like that. Hundreds of lines of hard-coded database names, host names, passwords, usernames. Always the same, of course. Horrible. So, fuck that shit. So there's this nice thing called the connection service file, or pgservice.conf. Looks like that. It's just a file, text file in a style format. You have a name of something called a service, and then you can define connection parameters mapped to this service. Database name, host name, username, whatever, password. Anything you can provide to connect information. And then in your code, instead of having the hard-coded database name and the username and the secret, you just reference the service, and then that's it. Or you could use a method or a function to calculate the service name, so that's something I'm using sometimes. Return the name of the service. Or if I'm using the test, return a different name for a different service. And then in the PG service configuration, I say, okay, for the regular database name, use that database, and for the test database, use some other database, maybe using different usernames, whatever. And of course, on a different server, you can have a different configuration with different database names, different usernames, different passwords, whatever. So the application just defines the abstract service that it wants to use. And the how, like how do you actually connect to the database using that service is defined in this file. And you can have different files with different services, different environments, which is sort of a nice separation of concerns. You can also use it from the command line, so instead of that, you just say that. Don't need to remember the passwords. Of course, now the password is lying around in the file system, so you have to make sure that the file system is secure. Another nice thing we're using is a method to calculate the service name based on the actual script we're using. So we have this db service function, which is now a bit bigger. It has a base, and it returns the base with underscore test if you're running the test. If we're not running the test, we're getting the name of the current binary by calling $0, which returns something like that. Then we do some regular expressions on it to get rid of that stuff. And then we concatenate the base and the thing together, so we get stuff like that. So depending on which script we're running, we're having different service names. And then we can define different configuration settings in this file. So on the live server is that, on my laptop is this. And then we can do stuff like, which is also quite nice and people do not often enough. So usually you have like one database connection for your whole application and grant everything to everybody. So that's what we're doing here for this application. But for this other script, which just generates reports, it's using another user called generate report. And that user has a limited set of permissions. That's something you should do, in my opinion, to trim down the rights of each user. And PG Service makes it very easy because you're not just using one database connection for all your code. So PG Service conf makes it quite nice and easy. Okay. So back to this database I inherited from somebody. And I took a look at the relations. I found that all of the relations belong to an actual username. It wasn't actually Hans, that's just to protect the int. So that's again a fact, because on my laptop I don't want to have a user called somebody, and definitely not in the production systems. So we had to change all of those to something that's meaningful, which is a lot of work. You could write a script to do it, which is also a lot of work and too complicated. And then I learned that there's something called reassigned owned. So you say reassigned owned by old role to a new role, like that, and done. So everything now belongs to the new role. Everything previously belonged to the old role now belongs to that role. That's quite nice when you get a crappy database from somebody and then to make it a little bit nicer. I suck at typing, okay, that's an old problem. So you type this nice query, and of course there's a typo in here because this table is not count account, but it's account. And then you have to go like backspace back. Yeah, that's not very fun. Luckily, Postgres has this thing called \e, which just enter into the prompt, and then it starts your favorite editor, which is of course Vim. And then you can do just substitute that with this, write the thing, and be done with it. So that's very nice. If you have long queries, you don't have to copy them into a separate buffer and copy them back. You just hit \e, write your query in your editor, and be done with it. You can even save the queries then from the editor to the file system for data usage. Or load them. Typos are also aborting transactions. That's also quite annoying. So I sort of started using that after doing a delete from table foo where blah is x and forgetting the blah is x part. So if you're hitting the shell, you just type begin and then do the stuff. So you're safe. If you fuck up, you just can do a rollback and not have to dig out your backups, which you hopefully have. Stuff like that. Anyway, but if you do that and you insert something and you have a typo in here, because it's values and not value, then the transaction is aborted and you have to type in rollback and do everything again. It's sort of annoying if it's happening by mistake. So you have this thing on error rollback interactive, which you can set as a config parameter. And then you can do as many types as you like, and the transaction is not aborted, and you can just continue doing your stuff and then to commit when you're done. That's quite nice. Too much data. Okay. So you select something from a database, and then you get back this piece of garbage. It's impossible to read, and very hard to figure out what's actually going on. So there's \x, which turns on the extended mode or something, and then you can select the same thing, and you get back this nice tabular output where the table is flipped around 90%, and you can just actually read it. Very nice, and makes it a lot easier. Okay, a little bit more complicated from two dates. So you have a table where we store some terms, doesn't really matter. Has some stuff. The thing is, it has whatever we store has a valid time frame. It's valid from some timestamp to some timestamp. Usually, it's easy to figure out from which time it's valid. So we default to now. So if you enter something in the database, it's starting to be valid from that timestamp. But the question is, how long is it going to be valid? You don't know it in the beginning. So if you do nothing, you just have nulls for basically when you don't know it, you can have to do that, which is stupid, annoying, too much typing, chains have a lot of typos, so it's not very nice. So you can do something like that, have a default timestamp verified in the future, and then you can do that, which sort of works, but the problem is, of course, what happens if you happen to live until 2000 to that date, and then you get a call at your New Year's party and you're 124 years old, so that's not fun. So don't do that, especially because Postgres has this thing called infinity. So you can set the default of the timestamp to infinity, plus or minus, and then you can just do that and do it. Very nice. If you want to query that stuff now, so you want to get which terms are now actually valid now, so you have to do something like that. Or is it that? How do you do this? Bigger and smaller? I don't know. Is it that? Or I always get it wrong and get confused by that stuff. Luckily, Postgres has something called between. So you can do A between X and Y, which also ends up doing something like that. So you can, to get the valid things now, you say select something where now is between valid from and valid until. So it's just something you can read and understand, and very nice, I think. So I did this talk at Yapsi like 1 month ago, and who was it? Somebody said Postgres has this thing called ranges, which is even nicer. And I said, okay, nice. I sort of read about it once and then forgot about it again. And so I took a look at it again now. So you can have like one field called valid, which has a type TZ range, and defaults to some range. In that case, it defaults from now until infinity. This last part here is if it should include the timestamp or exclude. So is it bigger or bigger? Yeah. You get it? I can. So you can do that, and then you can insert stuff like that. Then it gets the defaults, or you can insert stuff like that. I think that's the reason why I actually didn't use it, because it's very hard to actually insert data. Maybe there's a smarter way to do it. That's what I found out when googling about it yesterday. So you have to call this function tz range and then define the ranges you want to insert. So this is going to be valid from tomorrow until infinity. Or you can have some explicit timestamps like here. So this is valid from some days in the past to some days in the future, as of now. And then you can just use this thing, the party head operator, I don't know. And some different other kinds to say you want to have the ranges which are valid now, and then you get back the data. So it's also quite nice from a feature. I guess it's rather hard to use something like that in something like a DBX class. I mean, it's of course doable. So maybe that's even nicer than using those two distinct valid from valid until things. I'm not using that now, but I found it interesting, and I just learned it like 1 week ago. CSV exports. Okay. So I used to do stuff like that. Customer comes and says, oh, I need to get the data from this table, and then you write this stupid script like 100 times. It's wrong because what's if the new line in the data? Yeah, you should use text CVS or something like that. And that's very annoying, especially because Postgres has this thing called copy as CSV. So you can just have any random query and put this stuff around, and then you just export a CSV file to where you specify. And you can even have different delimiters, different formats, and headers or not, no headers, and some other options. So that's quite nice and easier than to pick up a stupid script every time you need to export something. Of course, that's something I learned already knew, \O. You can say \O in some file, and then whatever you select will not go into your shell, but just into that file. So it's some very easy way to get some data out. It's even nice if you use \T. \T turns off the extended tuple mode or something it's called. So usually if you do something like that, you select something, you get back this thing, you get the column names, these dashes, and then the number of rows, which is nice if you want to know what's happening. But it's sort of annoying if you actually just want to get these IDs to put them into some other file, into some other system. So if you do \T, then it turns this off, and then you can do \O into some file, and then you have just the IDs in the file, and you can take them and put them in some other script that you can put do some stuff without having to delete stuff in that file. So that's quite nice, and I use it quite a lot in the last few days. Okay, a little bit bigger in job queues, event notification. Of course, there's stuff like UKP, Reddit, Radius, blah, 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 a lot of stuff. But yeah, sometimes you don't want to add another piece to your Jenga tower of stuff you have, because you already have Postgres, so you want to use Postgres for event notifications. Postgres has this thing called notify, which you call like that, so you say notify and some name and some payload, and then nothing happens, unless somebody listens actually on this like queue name here. And so if you do that before, then you get something back like that. So there's something happening. And you can use it to do notifications between different processes. So for example, you could have a worker running somewhere and the server running somewhere else. And in the server you say notify blah, and then you have a worker which just uses DBH to connect, say listen to this queue. And then you call pg notifies, which gives you back an array ref of notifications, which gives you one notification back. There's an array ref consisting of that stuff, the name, the PID, and the payload. I don't care about the PID. And then you can do whatever you want to do with it. There's a modular cPanel called job machine, which uses that to implement a sort of proper queuing system, which actually stores the stuff and does error reporting and so on. It's quite nice for a small and easy to set up job machine system. You can of course also use that thing in a trigger. So here we have a table which has some stuff and some data. And then we create a function which returns a trigger. So in the function we say, okay, if the operation was a delete, then call this notify method with those parameters, like the op, so this would be delete, the type of the thing that was deleted, the ID and the modification timestamp, concatenate it together using with the semicolon in between. If it was an update, do the same, and if it was an insert, do like more or less the same stuff. And then you can actually create a trigger that calls a function after each insert, update, or delete on this thing, do that notify stuff, and then you can somewhere else connect to a database, listen on this queue, and then if somebody else, in another database connection, does something with a thing, the trigger fires, and your worker gets a notification. So that's quite nice if you want to, for example. So we're using that for one thing where some microservice thingy where we need to synchronize, notify another system that something changed here. So we have this, so we have a worker like that that's listening on this channel or on the name of this job queue, and there's any event thing should be changed to async, whatever. It's a timer, it checks every second. So once a second it calls a callback to say are there any new notifications. If there are notifications, does this get the pg notify stuff, gets the payload, and then ends the notification, and notification, unpacks the payload, and then does something with it. What we're using is we're doing an HTTP request to some other service to say, hey, this thing changed, and we need to update something else. Quite nice, I think. I mentioned JSONB in the slides earlier. It's a new data type introduced in Postgres 9.5 or 9.4, I think. JSON is older, but JSONB is a new one. It's JSON binary. It has a bit more features and is a bit faster. So you can just define a column with type JSONB, and then you can insert JSON into the database. But it's not just like a string of JSON, it's actually JSON, and Postgres can do stuff with it. So you can move MongoDB to Defnal and stuff like that. Oh, really, Postgres is, you can use Postgres as a key value store and use all of the nice properties of Postgres at the same time. So you have the key value store, you have the document store for document stuff, at the same time a relational database, which is very nice. And the job queue, yes. So here you can use a select data and then use this strange arrow thingies to get the birth date out of this thing, and you get back the birth date. So you can actually access the data inside the JSON without having to extract the JSON into your application, unpack the JSON, stuff in your application, which is always bad. Do the stuff in the database. You can do stuff like that. So you can cast the string to a date and then call H on it, for example. So you get stuff back like that, because Postgres also has very awesome date time handling and date functions. You can use it in a select, so you can say you can store the birthday in a JSON and then have a select like that, and say, give me all things where the age is 20 years. And it's just working. Without having to do a map reduce or I don't know what. I haven't tried that yet, that one, but I found the documentation, so you can also do partial updates inside the JSON document. You don't have to update the whole document. partial updates inside. So you have to use this JSON sets and then the strange format thing. And then the name is updated, and that's nice. All of those require, at least this JSON set definitely requires 9.5, which is like 1 year old or 1.5 years old already, so it should be available everywhere. So I think that's very nice. Stupid curious. So we have this project, doesn't really matter. The thing is, okay, you cannot really see it very good here. Campaign stuff that you can do. And each of these things has some things. For example, a user has already participated here, but he hasn't participated here. He gets some points. There's a chance of winning, so that many people have participated. This user didn't participate. Here, that many people participated, and this user already got two raffles or 2 tickets to this raffle. And so we have a lot of those things. We need to get all of this data out of the database to present it to the user. That's actually it. And we use something called common table expressions for that, KACTs. So we used to have some very stupid queries, which are very slow, and then we use that thing. I like to think of common table expressions as very temporary helper tables that only exist for the context of this one query. General syntax looks like that. So you have something you want, that's like the temporary helper table you need. You need to get some data. You pack it into a with statement and give it a name. And then you have your regular SQL select statement where you can use this temporary table, the common table expression, as if it was a proper table. Nice thing, of course, is that this thing is only executed once before the query starts, and not for every row, as sometimes sub-selects are. So for this thing, we have a few questions, like which of those campaigns are currently active, are expired, or are pending, like upcoming. Has a user already participated in one of those campaigns? If it's a sweepstake, how many tickets has this user got? And how many tickets have been issued in total, so we can print out this chance of winning. This is the database, so there's the campaign table, which has an ID, some typo, and some data. Very simple run-of-the-mill table. And this is the table joining the user with the campaign. It's also a very simple linking table. So which campaigns are currently active, expired, or pending? Looks like that. Uses this trick where I do a select. So if now is smaller than valid from, that returns a boolean, and I give the name as it's pending. Yeah. So I just get back a true or false value named pending, and the same for expired. And then I use again this JCP feature to grab into this data structure to get out the points, whatever that is. So that's like the base query. How many tickets have been issued in total is just a simple join between the count on the campaign and the user to campaign linking table. It's very simple, just count group by one. I don't know that. Group by one is also not. Group by one is, I'm not sure if that's a Postgres feature or a SQL feature. So of course it references the first thing, so you don't have to write the name of the table in here. Also somebody, not all people know. The name of the column. Which campaigns has this user participated in and how often? It's basically the same query as before. You want to have the campaign names and the counts, but limited on this one user. And putting it together again using this generic common table expression syntax, which looks like that. So you fill in all these queries. You can also have several common table expressions in one query. So here we have two. We have one participation user as blah blah blah, and another one is participation total as blah blah blah. And then we can use those tables in here just as if they were proper tables. Join everything together, blah blah blah. We use left join because not all. We have 20 campaigns, and the user hasn't participated in one. Using the left join, we can get back the null values for those campaigns. Just regular left join. And then we get back this nice table where we can just see everything in one view. Like this one is still pending, this one is already expired, nobody participated here, the user participated in this thing, Here the user participated, has that many tickets, the user didn't participate, but that many tickets in total, blah, blah, blah. So it's one very fast and easy table, which resulted in this improvement in our performance, which is quite nice. Okay, but this was a very stupid implementation earlier, so. But it still was nice to see this graph later on. Window functions, that's group by on steroids. Again, the same table as earlier, but now we have campaign status, so each campaign has a status that we change. So you enter the status every time the status changes. So we have for one campaign it has created, modified, edited, approved, published, deleted, whatever. So what we want to know is what is the last status of each campaign in a set of campaigns. That's a query. We just select campaign status and campaign, join together, that's just basic SQL. The core fields also basic stuff. And the interesting thing is the rank, so the rank function. So we want to call the rank function, which gives us a rank. And we do that thing over, which says, okay, basically group by campaign ID, and then order this group on that thing, on the created timestamp of the status. Okay? So we get something like that. We get the group by on the first campaign, and depending on the timestamp, so that's the recent edit, second recent, so that was the first one, so you get the rank again. Okay? And the same for another campaign. Which is quite nice, but not really what we want, because what we actually want is only those two lines. So what we now do is we pack this over query into a common table expression. We call it last status, and then we can, from this common table expression, we can just select where rank is 1. Okay, so we get back that. Very nice. One simple query, and you get back the stuff you need. You don't have to do it in your application or whatever. Okay, it's already the last one. Trees, that's always sort of annoying, so sometimes you have to do stuff with trees. And trees are very complex. I hate them, but Postgres has this thing called with recursive, that's a special form of common table expressions. It's a tiny bit complicated, and I hope I get it right. So the idea is you have this with recursive thing, and the generic form is you first select the root node, so you select something, which is the root node of your tree, and then you do a union, where you select a child node, and the real trick here is that you can, inside the second part of this union thing, you can reference the parent, like the previous query. That's one level up in the tree. Okay. So you can match the child node parent is tree ID, tree is the previous entry, and child node is like the current one you want to output. And then you can just select everything from this tree. So here's an example I had together yesterday, which is based on some real stuff, but it's a little bit simpler. So we have a node, which is an ID, it has a parent that references it's the same table, and it has some name. So what we actually want, we want the ID of the thing, we want the parent, we want the level, so how deep is it in the tree, and we want the path, which is like the path. What's the location of this node in this tree? So we want to get that. Okay, that's a simplified thing for the root node. Select the ID, the parent is 0 because it's the root node that has the level of 0, and select the name of this node as the path from this node. So that's very simple. What probably should be here is where ID is that equals parent. Sorry for that. So in here it should say and where ID equals root node. Yeah, this would work. Then do the union, which basically together with recursive does the magic, and then now you're in the second part of this query. You can reference this tree, the common table expression tree, which you're defining it now, but you still reference it. It's not there yet. So you can select from that thing, and then you can link parent node is a child node, like that, even though they're just starting to exist here. And then you can also reference the columns of the parent node. Like here, I can say, okay, I want the node ID in the node parent, that's like the child. But from the parent, I want the level +1. So now I'm in level 1 or level 2 or level 3. And I want to concatenate the path together to use the path of the parent, / and the name of the node. And then you select everything from this common table expression, and you end up with something like that. Which is, I think, very nice. Yeah. So the node, the parent, the level, and the path. Forget the values, doesn't matter. It's just stuff from some live database. I think that's it. So do you have any favorite Postgres features that I missed yet? Or any questions?
Conditional updates.
Conditional updates, okay. Yeah, tell me more.
It's you can try to insert a node in Postgres, but if it already exists, the exception that gets thrown can be turned into an update.
So it's like upsert.
Upsert.
Okay.
So I played with that for the summer. This is why it dropped out of my head. But it was extremely useful, especially in combination with JSON updates.
Yeah.
So that really worked out very well.
Yeah. So upsert is basically like find a create in UX class. But on
No, in Postgres.
Yeah, but it's in the database. It sort of behaves like find a create in UX class, but it's implemented in a database and doesn't have to do 2 database runs.
But you can trigger much more. So
yeah.
You can.
Of course, it's more powerful.
If row exists in the view or something, insert a whole lot of other tables and stuff and reference things. So without doing any round trip, you can actually execute everything in Postgres.
Okay.
With the JSON, cannot be a sort of multi-level structure, sort of deep structure as opposed to simply validation.
Sorry?
With the JSON, can it be more just...
Yes, it can be, it can be a complex document with subtypes, with arrays and patches and stuff. And then that's, maybe I didn't mention it, you have this arrow with two curly braces and with one. So if you call just dash one arrow thing, you get back a JSON object. And if you call it with 2, then it's stringified. So if you want to access like the actual value, you can use 2 strings, but you can also say foo, arrow, bar, arrow, element, 5, arrow, blah, and then grab into that thing. There is, I mean, I didn't use a lot of those advanced or more complex things, but I think there are some ways where you can actually say, does this array exist? It gets complicated with arrays, sort of, to query them properly. But it's sort of like it's a new feature, so I guess they will add new stuff as users demand features. Yeah.
The recursive query that you showed.
Yeah.
Would there be scenarios that that's preferable to use over doing it by hand in Perl?
Yes, you can page, for example. So you could say here, limit 10. Start by 1, and then
you
just...
don't have any round trips.
You don't have any round trips, yeah.
A million times faster.
It's always faster to do in the database than in the application. Especially if you limit the data set. I mean, of course, you get all the data and then have to process it, then it doesn't really matter. And it's easier to do it in Postgres, do the Perl in Postgres and do the Perl. But if you do stuff like that, so you could say, I only want rows 100 to 110 in here. And if you do that, if you want to do something like paging on a tree in the source code, in your application, you have to fetch everything with the tree and then discard stuff. I mean, you still have to build the tree in here, but then you only have to fetch like the stuff you actually need.
Can I control with recursive statement whether it's going best first or
breadth first? I don't know. I don't know. I think I read something about it, but I don't know. Okay. Yeah.
I very much like Postgres XML features.
Okay.
Because you have lots of querying options, even for XML documents.
Yeah. That's true. Yeah. So Postgres has XML way longer than it has JSON. And I think you can basically do XPath statements on the XML documents in your database. So if you have XML documents, or if you like to suffer and work with XML, or if you have to suffer and work with XML, the more likely case, then you can just dump the XML document into your database and then XPath stuff on the database. At the same time, joining it to another table. So you have, it's also a nice thing with the JSP. So you have user, which is a regular database row, and then the data, and then you can say, join from table where user is blah 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 and JSON data blah 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 is something else. Which is much nicer than doing all of this stuff in the only document database.
I don't know if you've mentioned it because I was there.
Okay.
My favorite feature is like select from updates, skip locked, and doing job queues for that. So it's nice if you insert just jobs, just an ID, then Klausner is Perl pre-fork to just spawn a few identical copies, and then each one selects for update and skip locked.
Yeah. I didn't show that part in this presentation, but you've seen it twice already. So in the previous presentation, there was each of those examples had a bad example before, yeah, where I showed some very stupid stuff I did, and then the smarter one. And one other solution for the stupid part was the skip lock thing, which is also introduced in Postgres 9.5, I think, or 9.4. Yeah, 9.5. Which is quite nice. So you actually have table level, row level locking in Postgres. So you can say, I want to lock this row for access. And then with this new skip lock feature, you can say, just make it invisible. This row is locked, and if you select it, it doesn't show up anywhere, and it's ignored by everything until the lock is removed. Okay. Good. Then, thank you.